This is the BioImpact Silicon Valley, a series of 5 interviews of key players in the biotechnology space. They shine a light on why do we actually need biotech in our world and why we should care about it. Enjoy. Hello everyone, so this is the BioImpact Silicon Valley interview series. It is 5 interviews from key stakeholders from the Silicon Valley working with biotech companies, and we really want to show the why of biotechnology. Today with me we have Gregory Theyel. He is from the USA. He studied industrial engineering, got his PhD, and then moved to the Cambridge, UK, where he was responsible for also manufacturing practices all around the country, and focused a little bit later in his career about bioscience and biomanufacturing. After his stay as a professor at Cambridge, he moved back to the Silicon Valley and now has built a company that is called Biomanufacturing Network, and is advising all the startups, or even, small and large companies around biomanufacturing. So I'm super excited to talk to you today. Welcome.
Great, thank you, Mikhail.
So the goal of this interview is really to inspire people to be interested in biotechnology. So my first question to you is, what attracted you to life sciences, biotechnologies, and your industrial background? So how did you shift to this industry? What was the spark? Yeah, what was the spark?
Thank you, and thank you for the nice introduction, because that has some of the details on the answer to that question. I spent several years touring around the United Kingdom, visiting with manufacturers, and I visited with aerospace manufacturers, electronics, advanced materials, and life science. And it was fascinating how different those different sectors are, and how the people were motivated by different things. And I'm generalizing. My sample is probably about 100, between 50 and 100 companies during a 2-year period. And so the aerospace folks were so excited about amazing rockets and satellites and aircraft, and that was really almost kind of like almost a museum trip to go in and see these incredible machines. And the electronics folks was very kind of operation oriented, and same thing, the materials people, it was very kind of chemistry driven. And then the life science people, a fascinating array of innovations. But what was most noteworthy to me was the passion that the people had to do good. And when you're interviewing people from 4 different sectors, and you have hundreds of people that you've talked with, you start seeing clear patterns. And the pattern I saw more and more was that it wasn't so much about making huge amounts of money or even having grand engineering accomplishments. It was about saving people's lives or improving the quality of people's lives. And so in some ways, for me at that juncture in my career, it gave me a chance to decide who I wanted to be working with. And as impressive as the aerospace was, it truly was like almost an amusement or an amusement park or a museum trip to just go to these factories. That was really, really eye-opening and fun. But it really touched me to see what scientists and engineers were doing in medical device and biotech companies. And so that's how I got hooked. And so when I left the UK and returned to the United States, I had the opportunity to, in effect, choose how did I want to share manufacturing engineering capability, particularly because I was part of a couple of grant teams, and we won some money to help companies. And so I chose to focus in on medical device and biotech companies, because I really liked the way people in that industry were wired, what they thought about, why they did what they did. And so I think that's my attraction. The overall sense or ethos of helping people and And I wanted to be part of that. And I thought I could play a really small role of helping people in those in companies in the life science industry scale to manufacturing, because I knew manufacturing, I knew manufacturing engineering, and I wanted to help them with that small piece of the puzzle.
That's awesome, and I can feel what you just said, because I've been to many healthcare conferences, and I also started to be passionate about healthcare. I am a chemist by training, right? And I also studied all of the industry, space, quantum physics, like a stone that you use in the ceramics to cut your food, anything. But healthcare, I could feel the passion, so I can totally relate to that. And thanks for sharing. I love the excitement. I would like to move to the second question. You built a company that is called the Biomanufacturing Network, and to operate, you received a grant. What is this problem you're trying to solve? You said you want to save lives, and this is amazing, but your expertise is solving a problem, right? And why do we need your expertise? And maybe you can really share here about the importance of the ecosystem and how you actually make this happen, that people work together.
Well, yes, you've either read my mind on part of the answer. I started out thinking, oh, I'm an engineer and I'm going to do engineering type things. And what I've evolved into, and I say this with humor, but I've evolved into a concierge. And in fact, many people have, not many, maybe a dozen people have introduced me as a connector or a concierge. And it used to bother me. And I used to think, no, I'm not that. And now I embrace it. And so what the Biomedical Manufacturing Network is doing, and what I'm doing, is we understand the network, and we understand the needs of companies and how they can fit into a network and benefit from it. And what I mean by that is, when I work with a company, when I meet a person running a company, and they're often small, it could be 5 people, it could be 50 people, but they tend to be in that range, and they do a few things pretty well. They've either identified an important problem, or they're developing a certain piece of technology, but there's a huge number of things that they are not aware of. Simple things that, I say them simple because I know them well, but connections to contract manufacturers, ways to find a specialty adhesive, one type of sensor versus another type of sensor. I think there's a perception that people can just Google something and they'll find the answer, and that's not quite true in most cases. Most cases, it's the specialty insight that a network can provide, and without it, it becomes an important missing piece in a puzzle, maybe, or even an important part of a larger system. And so without it, the system doesn't operate nearly as well. And so what the Biomedical Manufacturing Network does, and what I do, is we make the connections to these important pieces within this larger system. So,
can I ask you, I love the mission you're on. So people understand the context. I saw your work because you came to the company I was working with, which is Bayer Pharmaceuticals, and you show us the different pieces. What is an important concept that people have to understand, right? Because they cannot stay at the same place when they grow, right? Can you quickly, slightly go on that topic and how that works until you make a small molecule or a protein in the lab, and then you go to scale and you just impact so many lives? Yeah.
Thank you. I appreciate the question, actually, because not only does it get to what we do in our work, but a really interesting part of my research, my personal research, and that is, there's lots that's been written about clusters, and especially clusters, in this case, life science or biomedical. But what I have found that is within a cluster, there are areas of that cluster that are more specialized for companies as they grow, as they evolve. And so, and those are spatial. So not only is it functional or resource driven, it's spatial. So in other words, if you envision a round organism, that organism then is subdivided into sub circles or sub clusters, And those subclusters actually have more specialized resources. So let me tie that to an example. A very common spatial move within the Bay Area is to develop your molecule in places like Berkeley or Emeryville or South San Francisco. And then once you've developed that, once you've worked your way through clinical trials, and it's time for you to scale up to manufacture that molecule or manufacture that vaccine, you move to a place like Fremont, which is about 30 miles away. If there's no traffic, it's less than an hour usually, but it's almost, from an operational point of view, a completely different landscape. So from a highly clustered area with entrepreneurs running around kind of between their startups and kind of this startup milieu of grant funding and clinical trials, to now a landscape that is less vertical as far as buildings and more spread out production facilities, and more of a kind of not an office park setting, but an industrial setting, warehouse setting, where inside each of those buildings, someone's scaling up a facility to then take that really good idea that made it through clinical trials and go into production and make lots of doses of a vaccine or lots of pills. And so close proximity in a global sense, 30 miles away, but substantially different within that one cluster. People think of the cluster being the San Francisco Bay Area or the Boston Cambridge area, but there are these subclusters within each of those regions that focus on different parts of the company's evolution. And so I hope that answers your question. I tried to keep it concise, but it's been a fascinating thing to watch spatially. And the way I did it was, and thank you for bringing this up, but the way I did it is I tracked 100 companies that moved during a 5-year period. And I interviewed them. I said, hey, where'd you go and why? And so 45 of the 100 moved out of the cluster, because they said they needed to have a really low cost location because they now were making a commodity. All right, that's fair. That's a strategic reason to move. The other 55 moved within the initial cluster for different reasons. Some moved to an area where there are lots of venture capitalists, right in the Palo Alto area and Menlo Park. Others moved to San Francisco to have access to certain types of talent. Some moved to South San Francisco, actually, so they could be closer to scouts, large pharmaceutical companies that were looking for companies to acquire. And then a whole nother group, about half of that 55, moved to places like Fremont, Newark, Hayward, to scale up their production. Yeah. And so again, different strategic reasons.
Yeah, no, I love it. So to sum up, basically what you did is you came to the Bay Area, you tried to understand, let's say, really the ecosystem, right? You try to understand the companies and the different strategies from mid-sized, small, big companies. And from the research now today, you try to help all these companies because you saw the pattern, and like this, you can help them to scale and to impact, right?
Right, because the bigger lesson, to get at what your question, is that different companies at different stages of their evolution need different resources. And so as you're scaling up your manufacturing, you need a different type of facility, you need different types of suppliers, you need just different types of partners and different types of employees as well. When you're at the research stage, especially the initial research stage, then you need different type of people as well, and a different setting is more conducive. When you need money, you go to where the people are giving you the money want you to be. If they want you to be close by so they can keep an eye on you, then that's the reason you go there. Or if you want to go there to try to attract that money. And I call them microclimates. They're microclimates within the larger region. And each of those microclimates had different personalities as far as access to employees, just access to different types of infrastructure. So yeah, but it really got to the types of resources a company needs at a certain time in their evolution. And the network, the Biomedical Manufacturing Network, that's one part of our charge, is to get the companies in the right place with the right resources they need to continue to grow.
Love it, love it. I think it's a fantastic work, and I will make sure to share the resource that are available with the people that will read the blog, read the book, watch this interview. So I'm sure they will be very interested by your work. Now I would like to move to the next question, which is, so we are in the age where biotech has gained a tremendous interest from society. I mean, that's COVID, right? Everybody is worried about the virus. Everybody is also worried about the vaccine. What do you say to people, because you're still working in a space, right? I know you're not an expert, but still, what do you say to people so they trust the science, to trust that we are not trying to, to bring strange bodies into their bodies, right? What do you say to them?
Well, and part of this is my training as an industrial engineer, because the core of industrial engineering is systems thinking. And I don't want to get too deep into the weeds of systems, but systems in many ways, whether they're ecosystems, is the way we've kind of popularized the concept, right? It seems more, I don't know, approachable to talk about ecosystems, right? But industrial engineers learn systems. And so I think the way to see biotech is that biotech is helping and enhancing in different parts of the system. So we all want food that doesn't spoil quickly. So we've enhanced our food. That enhancement of food has led to better nutrition and less hunger. And at the same time, it may have caused some other challenges, maybe certain challenges with immunities or some other challenges. And so then biotech is there to try to address that problem. And so there's causes and effects in different systems, and biotech is a common denominator in trying to help with an initial problem, but then also help with some of the unintended consequences as well. All of these are largely unknown at the time. They truly are unintended in most all cases, and so. But it's there as a set of tools to try to address those unintended consequences. So in other words, we go through life trying to make life better, whether it's new materials, biotech is that toolkit to do that. We help us find better materials, help us find better medicines, help us to enhance our health. But it's a tool set that's still there when something doesn't go perfectly well or we don't address the complete problem. And so I guess those are the two concepts I think of is one is the systems, the interlinking of systems and the cause and effects. And then the second concept is biotech as a set of tools or a tool set to try to address some of those challenges within the system.
Yeah, I love that. So system thinking is definitely something also to teach to people, right? So they understand also the entire concept behind that. So they see that as a tool, as you said, for the system. I like that. Very, very nice.
Thank you. Yeah, I mean, it works well with the book chapter as well, because it is a perspective. Because I think people can see biotech in many ways. They can see it as a way to make money. They can see it as a way to advance under our abilities to manipulate the environment. I just think, like I said, it goes probably back to my training, and that is I see that as an interconnected system. And that's what biology is. But I really see it. We live in this interconnected system, and biology is a tool set that allows us to work within that system and understand it, but also react to what happens within that system.
Nice. I love this sum up phrase. It was, I think, very more comprehensive, and I will definitely do more research to talk about this. I think it's an important topic to raise and to understand. I would like to go to the next question, and this is because everybody is kind of involved with it. It's gaining traction in the world of social media, scientific communication. A few years ago, that was not a huge topic, but now we have social media, right? 2007, iPhone come up, and today everyone has a voice, and we see it during COVID, like everybody sharing information. Nobody know who to trust anymore. Politicians are sharing things that are not approved by science. You have influencers sharing, people believe the wrong person. How do you see scientific communication moving forward, if you have to compare with the past, and what do you believe is a solution to regain the trust from the people?
Right. Thank you. An excellent question, and it allows me to talk about one of the events that I enjoy the most. Pre-COVID, I was invited to a lot of events because of the network I have, either to make connections or just because I say yes a lot, I guess. And one of my most enjoyable events was an opportunity to take high school students into life science companies, into biotech companies, medical device companies. And the reason, and I'll get to the answer to your question in a second, I like that event so much because the high school students, they're 14, 15, 16 years old. They had a really strong kind of curiosity in general, but had almost no exposure to biotech. And so this event, back to this high school event, the students were so curious, but had never been in a biotech company, had never been really kind of knew what they did in there. And that was fascinating because when you're in the industry, you think everyone kind of gets what happens in a biotech factory, or how drugs are made and how devices are made. It's not that complex, but that's not the case. And so what I think, let me get right to the point about communication, and that is a much broader understanding of science in just our general population. And I don't want to get preachy or political in this statement, because I really don't want to turn anyone off on this, because I think it's a really important point. I really think more people have to understand the basics of science and understand how it connects to our lives. So it isn't just about balancing equations, the things that maybe made your head swim when you were in high school or even earlier years, but instead to see the practical application. And to do that, there needs to be more kind of help on both sides of this. The teachers and schools need to take their students into companies, and companies need to open their doors to let people in. And so people can make that link between science and life. And so it isn't something that's separate or specialized for just certain people to understand, but that we all see us as part of this larger kind of science community. And I think that's a real challenge. I mean, whenever someone says, "Oh, I can't understand that. That's hard." No, that's not good enough. That's not what we need. We need to say, "Oh, how is this relevant to me?" If I can see tangible examples, then I can see that it's not just hard. Sometimes whenever we have specialized knowledge, we think we're in a club. And so we don't feel like we need to make it approachable, to make it understandable to everyone else, because we're in the club and they're not. I think with biotech and in science, I think that's completely off base. There is specialized knowledge, clearly, but we're all in the club of science. And so I think that's the way I approach this. And that's why that event has just touched me so much, because we worked with, there were 200 people, 200 students showed up for that event, and it was twice a year. So 400 students a year came to this event and went home knowing what biotech is. That to me, and I used to tell I chaperoned a small group, and I used to tell them, go home and spread this to your sisters, your brothers, your parents, your uncles, your aunts. Tell them, I've been to a biotech company, and here's what goes on in there, and here's how it matters for our day-to-day life. It's not mysterious. It's part of who we are, and it's part of life. So that's what I think. Just more transparency with companies and understanding that larger principle that we are all science.
Yeah. I love that example, and it's amazing follow-up discussion that we can do in the future about how can we make children more involved with science right at the beginning, and with practical, with the hands, and not just like on paper, because we know so many people. I mean, every scientist know friends, family that were discouraged at a young age because it looked terrible, and now they understand nothing. And then a few years later, they say that, a 5G antenna created COVID. And when you hear that, you're like, that's sad, right? It is sad. And so I believe your example is practical, is possible. And hopefully we can find ways to implement this more everywhere in the world. So thanks for this. Thanks for this idea. There's a question I forgot to ask actually before, and it's a very important one. Now you've been involved with so many med device companies, biotech manufacturing companies. What is a problem? So I know there's many problems to solve, but what is like a big problem that you realize biotech is solving, and that people should be aware that we are solving this big issue, one of the biggest issue of the world, right? What if you had to pick one, what would it be?
It may be controversial to people beyond the kind of this close circle of people working on it, but I work with cell and gene therapy companies, and the concept that I think is important for people to be aware of is that we can alter genetic code, all right, and that it isn't scary. We've been doing it as horticulturalists, as gardeners for a long time. We've been doing it with animals. We found characteristics that make a species or make an animal able to survive better in certain conditions. In a sense, adaptation. We as humans have adapted. We've in some ways, we've found the best crops and planted those in the right location. I mean, so a lot of it is we're manipulating a genetic process, whether it's overt and as far as with CRISPR technique, where you actually go in and change the genetic code, or whether we're doing it by just choosing out certain stronger strains of an apple tree, and so I think here's a perfect example of where just a tiny bit of knowledge about it is actually might be more harmful. And so in other words, you need a bit more than just a tiny bit, because at first, when I even just said genetic change or changing genetic code, just hearing that could be shocking and oh my gosh, that's horrible. But then let me soften a little bit by saying, hey, we've been doing it as anyone who has an orchard, and anyone who has raised dogs, and anyone who has done a whole range of different things. Anyone who's planted gardens, the whole green revolution. They've found, hey, this is a stronger strain of seeds and it works better. So I think a more openness to see the benefits, but also the potential challenges of changes in genetic code. That's what we need as a larger society, and not, just the specialists will be in charge of that. That will lead to even more fear. Not let's lock that back into Pandora's box and let's not talk about that, when in other ways it's all over the place because we've been hybriding things for a long time. So that mentality is not there either. But something in the middle where we have a more informed society about the opportunities, but also some of the challenges and some of the safeguards that we need to put in place. So I think just a whole range of kind of gene therapy and manipulation of genes and use of genetic material and insight. I think that's what I would highlight.
That's awesome, and I believe that you're not the only one that mentioned CRISPR and gene therapy, because it is a new science that is really transforming the way we live and the way we cure people, to cure diseases, and I believe it has tremendous potential. And I agree that the dialogue is completely not here at the moment. I mean, so many people still believe that this is bad and they don't get the benefit and how. So I love this example, and let's find solution after this interview in the future, how we can make a dialogue more open that people trust and that people listen to, right? So thank you for that. The last question that I ask all the guests on the show is, we want people to be curious. We want people to impact lives. And I experienced this. I'm very passionate about entrepreneurship today, and we can see it in this interview, but so many people are lost out there. And one of the reasons is sometimes it looks so big that you're so scared to start. What is your advice to young people or anyone that want to solve a problem and start something small? What is your advice about the process of doing that?
Sure. I mean, I'm sure there's many other people who have, educators in particular, who have brilliant answers. But let me give you my perspective. Thank you. You complimented me earlier for some of the graphics you saw that I presented, and so I spent a lot of time with maps, and so let me use that as an example, because you can use different maps. You can use different types of graphics, but I'll just use maps for a second. If you have a map and you share a map with someone, you can show them where they are on that map. And then you can show other prominent things on that map. You can say, well, here's where you live, and here's where the Taj Mahal is, and here's where the Eiffel Tower is, and here's where Big Ben is, and here's where Mount Kilimanjaro is. And so you start to say, oh, okay. And then you start saying, well, how far away is that from me? And you say, well, what would it take for me to get there? And why is it there? And you start seeing that it isn't so disconnected now. The map has allowed you to see how you're part of a much bigger whole. And you can go universe as well. You can say, here's the Earth, and there's the sun, and there's Mercury, and all of that. But I really think a map can be very powerful as a graphic to show you how you're part of this bigger conversation, this bigger community or network. And so whether it's a systems diagram, whatever the diagram is, I mean, I think if we can show people how they fit into that larger system or diagram or map, I think it's a way to feel like they belong, number one, which belonging is really important for everyone. And number two, how they have an influence on that larger system and how they're influenced by that larger system. So that's why I am drawn to maps so much, because that question of why things are where they are and why location matters. I mean, that's what I get excited about. If anyone says to me, "Hey, I've got a map to show you," boom, I'm all in, because of what we can do with them. So that's my answer to your question, in possibly a different way.
It is a great answer, and I interview you because I want your perspective, and you have accomplished something that so many young people dream of, right? You studied, you got a PhD, you were a professor at Cambridge. You visited the entire country to really understand a lot of problems of different industry. You moved back, you opened your own company, and now you're working with all these people and you're helping them to impact. And it is very inspiring. And your analogy to maps is great. I love it. I think it's, so you said belonging, seeing that, it is, you're part of this global structure, and basically that there are some system you can use tools to get there, right?
Yeah, I think so. And maybe in some ways it's the diagram, whether it's a family tree or whether it's a supply networks diagram or whether it's an electrical diagram. I mean, I happen personally connect to maps, and lots of people do. I present my research all the time, and I talk about a lot of different things. Like earlier, I was talking about the connections within a cluster as companies evolve. I talk about all those ideas a lot, but of the people who hear me, they hear maps. And so I think there's something about maps that people love, and whether it's from their childhoods, they love the atlas, and they spend hours of atlas, because atlases are awesome, right? Because there's 195 countries, and they have different flags and different languages, and then plus here's open 2 pages, and across those 2 pages are the whole thing right there. So I think there's something fascinating that from our childhoods, but I also think that. I think the belonging piece is really important too. There's where I am. There's where my uncle lives. There's where my grandmother's from. I think that's part of it too. I have a pen pal from there. I think that kind of connectivity is really important, and maps allow us to do that.
Love that. Let's finish on this wonderful word, connectivity. Thank you, Gregory. It was a pleasure to talk to you today, to get your inspiration. I can see the passion that you have for the work you're doing, but also to encouraging young people to be interested in science, and because we all need it. And I think we hope that this interview is going to impact lives. And once again, thank you very much, Gregory.
No, you're welcome. My pleasure, actually. Thank you for asking me these great questions.
Fantastic.
Right.